Alright class, this is the last, the first day of the last unit. Pattern recognition, defining and using sequences. So what is a sequence? A sequence is a function whose whose domain is a set of positive integers. So our inputs are going to start at 1. The variable n is used as the independent variable in a sequence. The terms of the sequence are represented by the subscripted variables a sub n. So for instance, if I want to know the first term, I would call that a sub 1, the second term a sub 2. When the formula for the nth term of a sequence is known, the entire sequence can be written or replaced by placing braces around the formula for the nth term. You could also write a sub n equals. Okay, so this says, let's look at this. Write the first 5 terms of the sequence. So this is our sequence, and remember, we want to find each term starting at when n is 1. So a sub 1 means when n is 1, I get 1 plus 4 over 1, which is 5 over 1. So the first term of the sequence is 5. Now I want to know what the second term of the sequence is. Well, a sub 2 means when n is now 2. So I get 6 over 2, which is 3. And so on and so forth. So let's finish this up. 3 plus 4 over 3, which is 7 over 3. Can't do anything about that. A sub 4 is 4 plus 4 over 4. 8 over 4 is 2. And the final one is 5 plus 4 over 5, which is 9/5. Alright, you guys could try pausing the video and try this one if you need to. Again, find the first 5 terms. So the first term is when n is 1. You get 1/2. When you have the second term, it's when n is 2. You get 4/3. When n is 3, 9 over 4 is 9/4. When n is 4, you get 16 over 4 plus 1, which is 16/5. And finally, when n is 5, you get 5 squared, which is 25, over 5 plus 1, which is 25/6. So those are the first 5 terms of the sequence. Now, you're going to have to go the other way. Excuse me, man. It's early in the morning. Haven't really woken up yet. Now we have to go the other way. 3, 4, 5, 6. We have to find out what the pattern is. Okay? So here you have to kind of figure out what's happening. We go from 1 to 2, which is either adding 1 or multiplying by 2. Then we go 2 to 4, which is multiplying by 2. Then 4 to 8, which is multiplying by 2. And then so on. So we know a sub 1 is... So basically, you can think of this, if you keep multiplying, that means you're raising 2 to a power. So that's 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth. This one's 2 to the 0. However, we always start with n is 1. So to combat that, we can say that our nth term of the sequence is 2. Normally you would say 2 to the n, but that doesn't work here because when you put 1 in, you start there. So to start where this turns into a 0, you have to make it 2 raised to the n minus 1. And now that should work. So when I put 1 in for the first term, I get 2 to the 0, which is 1. This is the second term. So when I put 2 in, 2 minus 1 is 1, so 2 to the first is 2. This is the third term. 3 minus 1 is 2. 2 squared is 4. So that one works. Alright, now we have to figure out what's happening here. It looks like we're multiplying by a negative 1. And it seems like it's going up by 5s. So that means that each term needs another 5, which means you're going to be multiplying a 5 to n. So let's see what happens with that. So I have 5 times n. Nth term equals. So if I put 1 in, I get 5. If I put 2 in, I get 10. If I put 3 in, I get 15. So this is fine the way it is. We get our numbers the way we want them. It's a multiple of 5 each time. But we need it to alternate a negative sign. So we're going to start with negative 1. And again, here's where you have to decide, do I want it to be n or n minus 1? Well, if I put an n there, the first term becomes negative 5, which is wrong. So if I put a minus 1 there, now it becomes positive, and then when it's the second term, it becomes negative. So that is what I want. This one's going up by 3s. So Usually that's a 3 times n. But what happens when we do that? Well, if I do 3n and I put a 1 in, I get 3. So what do I need? I need to start with a 1. So when I put a 1 in here, I have 3. What do I need to subtract off that? I need a minus 2. And then it should work. So when n is 1, you get 3 minus 2 is 1. When n is 2, you get 6 minus 2 is 4. And so on and so forth. With fractions, look at the top and bottom independently. Okay? So this looks like 2 squared, 3 squared, 4 squared, 5 squared, and 6 squared, where this is 1, 2, 3, 4, 5. So here's what you can do with this one. If n is 1, that's the top. If n is 2, that's the top. So the top of our fraction is going to be n. The bottom, though, we want a 2 squared, not a 1 squared. So how do I get to a 2? Well, it needs to be 1 more than n. So this is going to be n plus 1 squared. So now let's think about that. When I put a 1 in, I get a 1 over 1 plus 1 is 2 squared, which is 1/4. If I put a 2 in, I get 2 over 2 plus 1 is 3 squared is 9. So that does work. This is probably the hardest thing you have to do, is come up with the patterns. Okay. Next, a factorial. All right, a factorial is defined as, when you see an exclamation point, it's not that the number is really excited and exclaiming something here. It is a mathematical operation, which means that, well, first of all, 0 factorial and 1 factorial are defined as 1, so that's fine. N factorial means you just take the number that it is and multiply by all of its previous terms. Another formula is saying that if you have n factorial, it's n times all the previous ones factorial, or the previous one factorial. Since this formula relies on previous terms, it's a recursive function, and we're going to deal with those in a second. So basically, here's what 5 factorial is. 5 factorial is 5 times 4 times 3 times 2 times 1, which when you multiply it all out, 20 times 6 is 120. Okay? Now, I'm going to show you 2 ways to write this. 7 times 6 times 5 times 4 times 3 times 2 times 1. Or, how can we rewrite this? This is 7 times, and then 6 times 5 times 4 times 3 times 2 times 1 is just 6 factorial, right? So you could take one of them off and then say the rest is a factorial. Those are 2 different ways to do factorials. Alright, so now we're going to evaluate this fraction here. I'm going to write this out as 6 times 5 times 4 factorial. All I did was peel off the 2 times 8 factorial over 4 factorial. By the way, there is a factorial button in your calculator under the math, then move over to PRB, and it's option 4. So what's nice about what I just did is the reason why I peeled these off and got to 4 factorial is now I can cancel out the 4 factorials. So basically it's 6 times 5 times 8 factorial. And if you type that in your calculator, which I'll show you in class, and if you missed class, I can show you when you come in the next day, you would get that value. Alright, so here's what's important. A recursive sequence means you need the previous term. So notice how for all these problems, I'm telling you where we're starting. I'm telling you this is the starting point at 3, and here's what you'll see. You'll see any n term is equal to 2 times the n minus 1 term. This basically means the previous term. Because if we're at n, n minus 1 was the one before it. So let's see how that works. We know a sub 1 is 3. So a sub 2 is equal to 2 times a sub 2 minus 1, which is equal to 2 times a sub 1, which is equal to 2 times 3 equals 6. So basically what we did was we took the first term and multiplied it by 2 to get the second term. Now for the third term, we're going to take 2 times the second term. We get 12. Then for a sub 4, we're going to take 2 times the third term and get 24. And a sub 5, we're going to take 2 times the previous term and get 48. So those are the 5 terms. 1, 2, 3, 4, 5. So when you see that, that's a recursive. Whenever I ask you to write a recursive, you need to tell me what the starting point is. So this one is saying that you're starting at -2 and that we're doing 3 plus the previous. So a sub 2 is equal to 3 plus -2, which is 1. A sub 3 is equal to 3 plus the previous term, which is 4. A sub 4 is equal to 3 plus the previous term, which is 7. So you can see that this is just going up by 3's. A5 is equal to 3 plus the previous term, which is 10. Okay, so those are the previous terms, and those are all of them. So that's how a recursive works, though, and that's important because we'll be working with both kinds as we go along. I know this is a lot today because it's just all brand new, but it's basically the same thing every day except for when we add sums. So, all right, and that's it.